Welcome to the experimental video for Experiment 5. Brought to you by the University of Pretoria.
For this experiment, you are given a polystyrene solution, toluene, acetone, some beakers, and graduated pipettes, as well as parafilm and polytops. The first step is going to be to transfer 10 milliliter of toluene to a polytop vial so that we can transfer it from a fume hood to the water bath where the Oswald Viscometer is located. Since we will not use the pipette directly in the toluene bottle or reagent bottle, we first transfer the toluene to a beaker, and from there on we're going to measure 10 milliliter of toluene using the pipette into the polytop vial. So this is a Oswald Viscometer. It needs to remain clamped in the water bath because it's glass and it is quite expensive. The water bath is of course kept at a carefully controlled 25 degrees Celsius to keep the temperature equilibrium stable. And we now are going to transfer our 10 milliliter of toluene using a glass Pasteur pipette and a little sucker as shown here into the larger leg, the left leg of the Oswald Viscometer. Once your toluene is in the Viscometer, allow 15 minutes for thermal equilibrium to set in. So of course, as per your practical guide, this is bulb A, this mark here is line X, and this mark here is line Y. And we are now going to use the vacuum to suck up the toluene to above mark X and then allow it to fall down and measure the time. Connect your hose to the vacuum and ensure that there is a vacuum indeed being pulled through the hose. And now you're going to suck up the toluene to just slightly above the X line on the Viscometer so that you can precisely start timing the fall between the points X and Y. Start taking your time now. And of course, continue until it reaches the Y mark on the Viscometer. And there we see it passes the Y mark and you finish your time. So we've finished our first measurement of T0 for toluene. So now again, we need to suck up to slightly just above the X mark and have our stopwatch ready to measure our times between the X and the Y marks. And we use the same solution as before. We don't add any new toluene, we don't do anything to the system. We have just allowed the toluene we are just sucking up the same system as we did before. Discard the toluene into a waste beaker and use acetone to wash the Viscometer. Cleaning the Viscometer could be quite strenuous task since it takes a while for the liquid to pass down the one-sided leg. Just be patient. Now use the acetone to rinse your Viscometer. Remember, as always, be careful because the Viscometer is quite expensive. It's made of glass. Take a good amount of acetone and now you'll return to the bench top to further clean the side of the Viscometer. Then use the vacuum again to pull up the acetone to clean the other side of the Viscometer to ensure that the capillary tube is also cleaned. To dry the viscometer, you can use the vacuum. So once you've discarded all the acetone, to clean it, you can use the vacuum system to dry the viscometer further. Once you have cleaned the viscometer, of course, you can repeat this process for the pure polystyrene solution as well as the subsequent dilutions. And remember to repeat the process or take 3 time measurements for each of the different solutions. In other words, you repeat each sub-experiment 3 times. To make up these solutions, you will use polystyrene, toluene, and a polytop. You will also use 2 different graduated pipettes, and you will use the appropriate volumes dispensed from each of these solutions. So you will take the appropriate volume of the polystyrene solution, dispense it to the polytop, and of course use the other pipette to dispense the subsequent amount of toluene into the polytop, and then transfer it to the bench top and use again the glass Pasteur pipette to transfer your new made mixture to the Oswald Viscometer, and repeat the whole process over and over again until your times start to converge with your time 0 average. As with any practical, the most important part is the waste management, but especially in this practical, since we're working with highly carcinogenic materials, the waste management is even more important. So always transfer your waste to the correct waste bin for this experiment.